Hello, we're going to look at another example concerning sampling distributions for a proportion. So in this case, one way of checking the effect of undercoverage, non-response, and other sources of error in a sample survey is to compare the sample with known facts about the population. So we know, usually from the U.S. Census Bureau, that about 15% of American adults are Hispanic. The proportion p hat of Hispanics in a random sample of 1,500 adults should therefore really be close to 15%. So for example, if somebody's doing a market research study, you'd want your sample to be close to 15%. Now it's unlikely to be exactly 15% because of sampling variability. Now if a national sample is used for market research contains only 13.2% Hispanics, should we suspect that the sampling procedure is somehow underrepresenting Hispanics? Right? So what's the trait? The trait is whether you're Hispanic or not, and that's a yes-no trait. You either are or you're not. And the population is all American adults. Right? And what we know is 15% of American adults, that's P, are actually Hispanic, have the trait. And then here we're given a sample that's being used for market research, that's P hat. And then this word underrepresenting, this part under is telling us that we're wondering if there's too few Hispanics. So it's going to help us know which direction to shade, and that will be to the left. Right? So what we're going to look at then are writing a sentence for P and P hat in context, checking conditions to see that we can use a normal model, finding out what that model of the distribution of expected samples proportions will be, writing a sentence to interpret the 95% interval, and seeing what are the chances of getting a sample if we're only 13.2% or fewer are Hispanics. So write a sentence for P and P hat. So of course P is the proportion or percent of the population with the trait. All right. So in this case, P is the proportion or percent of the population is all Americans or all American adults who have the trait who are Hispanic. And P hat is the percent or proportion of a sample with the trait. And although we keep talking about sampling distributions and there's thousands of samples, P hat is the proportion of people or objects in one sample that have the trait. So we'd say P hat is the proportion or percent of all American adults in one sample who are Hispanic. Okay. All right. Well, let's go ahead and check conditions. So in our case, we're told the sample is random. That's actually in the problem. Let's see here. I know I saw it. Random sample, right there. All right. So we're told random sample. And now independent, you could use like if one American adult is Hispanic, it certainly obviously won't affect whether another one is. Okay. Or you could use the 10% rule, right? You could say N, which is 1,500. If I multiply that by 10, that'd give me 15,000, and that's certainly less than 10% of all American adults, right? So you could say that's less than 10% of all American adults. Be careful not to say that it's less than 10% of all Hispanic American adults, because that's just the people with the trait. When we use this, we want to say that the sample size is less than 10% of the population, and the population is both yeses and nos, not just the yeses. So be careful about that. And then representative sample, showing your success failure. You're going to say that P is greater than or equal to 10. So 1500 times 0.15 is 225, right? And then that's more than 10 are Hispanic. And then 1500 minus 225 is 1275, and that's more than 10 who are not Hispanic. So we're good on conditions. Okay. Now let's check let's see, since we know conditions were good, what is the standard deviation of the samples, and then we're going to go ahead and find the distribution. So the standard deviation of the sample proportions is square root of 0.15, 1 minus 0.15 over 1500. So I get 0.009. And I'm going to round that to 0.01, right? The 9 rounds this 0 to a 1. And here's the distribution of expected proportions. So 16, 17, 18, 14, 13, 12. Now we want to know what are the chances of getting a sample of 13.2 or fewer because of the underrepresentation. So we say, how far is my sample from the mean standardized? I get -2 standard deviations, and now normal CDF from -infinity to that value, or -100 standard deviations to -2, and we get 0.023%. Right, so that's, I'm sorry, 0.023, which is 2.3%. Sorry about that. Change that. Okay. So let's, actually I jumped ahead. Let me go ahead and write a sentence interpreting the interval, the 95% interval. So the 95% interval would have samples where between 13 and 17% are Hispanics in those samples. So I would say 95% of all random samples will have between, and again that's what, 13 and 17%. 13% and 17% Hispanics adults or Hispanic adults in the samples. That's what's understood. Okay. And then we found already, I jumped ahead, the probability of getting a sample proportion that's underrepresenting Hispanics, so that's right here, 2.3%. And since 2.3% is less than 5%, 5% is like a benchmark. If there's less than a 5% chance of getting a sample, that's unusual. Okay. And let me also just mention that you could have done this when you saw that this p hat of 0.132 had a z-score of 2 standard deviations. You could have said, well, you know, I know that 95% of all samples will be within 2 standard deviations. So that leaves 5% to be split. Part here and part here. So if we take 5% and divide it by 2, that means you'd have about 2.5% here and 2.5% here. So if you notice, this is an approximation. The more precise is 2.3%, but that's 2.5% is a very good approximation using the empirical rule. All right. So thanks for listening.